Hi everyone, today we're going to look into a list of separation techniques that are must-knows for the IB chemistry syllabus. And this is part of the first chapter of the IB chemistry syllabus, and a couple of techniques that we need to know are filtration, evaporation, distillation, chromatography, recrystallization, and thin layer chromatography and two-dimensional chromatography, both of which are not exactly on the syllabus, but they are must-knows in order to fully understand the properties and functions of paper chromatography. So let's get started. First, let's start off with filtration. Now, filtration is essentially the process to separate an insoluble solid from a liquid, and it does so by passing the mixture through a porous medium. The sort of equipment that we need for this process is filter funnel. We also need a filter paper, beaker. And the step for this is we firstly place the filter paper in the funnel, and we pour the heterogeneous mixture. Now, some of you might have heard the word heterogeneous, but you may not exactly know what it means. A heterogeneous mixture compared to a homogeneous mixture is one that has usually a non-uniform composition, and we can visibly see that there are more than one component involved. And sometimes a heterogeneous mixtures usually have like different states, various states in one mixture. After pouring the heterogeneous mixture, we will be collecting what is a residue, which is essentially a solid that's trapped in paper, in the filter paper that we discussed above, and we're going to collect filter it. And this is essentially just the liquid that's collected below, usually in a conical flask. Next, let's move on to evaporation. Evaporation is essentially a technique used in order to recover a dissolved solute from a solution by removing the solvent through heating. And what this essentially involves is we first heat the solution until the solvent evaporates, and we're essentially going to get the solid solute. The underlying principle behind this is solvent volatility, and if you don't know what I mean by that, it's essentially stating that boiling point must be lower than the decomposition point of the solute. Next technique that we're going to observe is